Alright, today we're going to talk about dividing complex numbers where the denominator is a binomial. So yesterday it was just one term, now we have two. So as a radical it could be 3 over 1 plus root 2, and as an imaginary 3 over 1 plus 2i. So what we would need to do yesterday was we just multiplied by whatever would make this a perfect square and whatever would get rid of that I to make it I squared. But unfortunately, if we just multiplied by I, the I is going to go with the 1, cancel out with the 2i, but then we still have an imaginary term. So what we need to do is we need to use something called a conjugate. So a conjugate is when we have two binomials that when they multiply together, the middle term cancels out. So x plus 4, x minus 4, those are conjugates of each other. And when we distribute, we would get x squared plus 4x minus 16. Notice how the 4x's cancel out, so we're just left with x squared minus 16. So let's apply that logic to these problems. So instead of 1 plus root 2, the conjugate is 1 minus root 2. I'm only changing that symbol in the middle because when I distribute, I'm going to have a positive root 2 and a negative root 2, and those root 2's will go away. And then the square root of 4 is just 2, so 1 minus 2 is negative 1. And then I divided by negative to get negative 3 plus 3 root 2. I'll accept this answer as well, but technically that is the more simplified version. Dealing with imaginary terms, again, instead of 1 plus 2i, I'm going to use 1 minus 2i. And then when I distribute, I'm going to have a positive 2i, a negative 2i. Those cancel out. The I times I forms an I squared, which is negative 1. So I get 1 plus 4, or 5. Alright, and I'll be posting some pictures of this and today's assignment, and then a guest appearance today of a little child pouting on the couch because I needed to take my phone to make this video. Yep.
Go away, little boy.
I was thinking the same thing. Go away, little boy.
No, go away, little boy.
Yeah, you're just a little boy?
No, Dad.
Oh, I'm a little boy?
No! You're not leaving tower ever.
And there's a little quote from Tangled. We're not leaving this tower ever. How appropriate.
You're not leaving tower ever.
What a nut job.